อ๋อแบตมันเหลือกี่เปอร์เซ็นต์อะไรไม่รู้เดี๋ยวผมไปเสียบให้เหลือเท่าไหร่นะจะพอไหมเนี่ยเดี๋ยวผมไปเสียบไว้ดีกว่านั่นแหละเสียบไว้หน่อยดีกว่าไหมแบบว่าเพื่อเขาแบบเจ๊งขึ้นมาเราไม่มีสายใส่ชาร์จหายไปไหนสายต่อที่สองโอ้หลายหมายเลขผมจำไม่ไหวเดี๋ยวคนนู้นไปห้องน้ำผมจำหลายหมายเลขไม่ไหวครับเดี๋ยวคุณจะรีบไปไหนเนี่ยตอนเช้าคุณก็ไม่อยู่วิบูลย์
ผมมาตอนเช้ามา
เลยคุณก็หายไปเลย
ผมหลับอยู่ข้างหลัง
อ๋อเหรอครับเพื่อความยุติธรรมใช่ป่ะ
อาจารย์ดูนี่
ข้างบนช่างไม่ไปเถอะครับวันนี้ไม่ผ่านขึ้นล่างขึ้นบนแม่ไปไหนหมดแล้ว
ขึ้นบนไม่อยู่แล้วผมเสียบนะยังครับเดี๋ยวเสียบชาร์จสักหน่อยก่อนครับกล้องมีปัญหาอะไรเดี๋ยวฝากดูด้วยนะว่าถ้ามันเจ๊งใช้ไม่ได้ยังไงเก็บพอชนะพอแล้วครับ
ได้ตัวเขาจะถึงแล้วกูโดนมาเลยด้วยเราไม่เปิดกินได้
เป็นแล้วทำอะไรไม่ต้องเกรงใจผมไม่ใช่เกย์ไม่เป็นไร
เกรงใจมาก่อน
แย่มาแล้วชนะที่เราบอกสู้แล้วได้ขอแล้ว
โดนแซงก็โต
เชิญเลย
ไม่ต้องเหมือนมั้ย
ให้มันร้อยเลยกูรู้แล้วนี่ก็บอกไปเป่าไอ้เมย์เรา
อารีวุฒิคิดถึงเพื่อนมาหาเพื่อนแต่ว่าไง
โดนแชร์เลย
ยืนแล้วแทนกันได้หมดเลย
อันนี้มันเพลงสอบเลยเปล่าเนี่ย
เมื่อจะโดนโดนดิ้งด้วย
ตกทุกวันเลย
โอ้โหเย้ก็เลยแชร์ก็เป็นเซ็กซี่อันนี้คุยพิเศษ
คณาวุฒิครับผม
ผู้ป่าโอ้ยจะฟื้นเบาเลยมันไม่ว่าเลยก็จะเอาผมสาวเกย์นี่นะกูโดน
60 years old
แค่ปรับเป็นกี้เสียงไทยเอาไปปรับกี้เสียงไทยเฮ้ย
ก็เจอเบสบอลเล่นได้เลยไม่แต่ที่เป็นเบอร์แบบตัดโซ่เลยไม่มีใครเห็นลูกโม่สัตว์
อย่ายกเมียวิ่งลูกๆไปจะไปเสียบมันแหลมอย่าทำกูนี่คุณพิเศษไหมเฮ้ย
ชยากรไป excursion ทำไมไม่ติดครับเนี่ยไม่ได้เสียบครับ
แม่กูคิดว่ากูเป็นอะไรเนี่ยกูแบกนี่ยังเติมแอปกับอะไร
ต่อไปก็คันวินกลับมาแล้วอย่างคันวินลาไปออกงานมานัทวัฒน์ครับอยู่ไหนครับธนากรทัศน์ครับธีรพงศ์ครับธีรพงศ์เหมือนยังอยู่เมื่อเช้าเจอครับเดี๋ยวขอดูตัวเป็นๆครับจริงก่อนเดี๋ยวคุณหลอกผม
ถ้าได้แบบไหนนะเปิดเพลงที่น้องกู้ไม่กันได้ยินไหม cover สด
แล้วเกิดเอาขาวพลาดยังไม่รู้ตัวเลยธีรพงศ์สลบเท่าไหร่ครับอนิวัฒน์โรจน์ระวีครับโรจน์ระวีช่วยยกมือให้ดูหน่อยครับสหรัฐครับสหรัฐโอเค
เริ่มต่อดิไอ้พวกคุณโดนเหลืองอยู่เนี่ย
สมัครครับสมัคร
ยิ่งเช่นเจอแล้ว
แล้วต้องเป็นคน
ห้องนี้ไม่มีคนชื่อสุภักอะไรอย่างงี้ด้วย
เป่าได้2 มือเลย
ฮะ
ด้านซ้ายเป็นเป่า
สุภลักษณ์ใช่ป่ะสุภลักษณ์ครับผมรู้สึกว่านักฟุตบอลทีมชาติไทยมีชื่อสุภักอะไรเยอะจังเลยฮะไม่น่าใช่ครับไม่อยู่ห้อง EP อ่ะพวกสุภักอะไรเงี้ยเวลาดูฟุตบอลแล้วผมงงสรุปคนไหนคือคนไหนใช่มันจะมีคนชื่อที่ทีมชาติสุภักอะไรเยอะๆ
สุภราชนะจ๊ะฮะสุภราช
สุภราชใช่ไม่ได้สุภาอะไรสักอย่างเยอะๆเลยด้วยชื่อตำรวจนีโน่ไปกิจกรรมแล้วก็แดนฟ้าอยู่นี่เชียร์คอนเดนิสก็ไปเอ็กซ์เกอร์ชันแล้วก็ คุณยูวี
เขาหลอกใช่ไหม
ฮะมันมีเดี๋ยวผมส่งให้เหรอน่าจะมีได้น่าจะมีไอ้จูเนียร์ส่งมาให้
โอเค let's continue our lecture okay this is one of the four series in beta decay it also includes the alpha decay and we start with thorium at 32 thorium has 90 protons and you go left right the number of proton reduces by 2 and the number of nucleons reduces by 4 so from 232 you're gonna have only 228 like this and after that we go left the red arrow here the red line here represents the alpha decay okay, which is helium 42 we go right and this color represents the beta decay and the number of nucleons is the same okay which is still 228 and the number of proton increases by 1 okay one of the neutron turns to be proton and we arrive at actinium and one more neutron changes into proton okay but the number of neutrons is the same 228 and we're gonna get thorium like this okay thorium and but this thorium is different from the beginning because it has only 28 nucleon. The number of proton is still same. 90, right? Sorry, 90. And once you go here, number of nucleons reduced by 4, and number of protons reduced by 2. You're gonna get radium 224. The radium 224 will turn down to radon 227, 220, and reduced by 2, right? 88, 86. And then it's gonna be polonium, okay, 4, and lead, which is 82. And one of the neutron changes to proton is going to be bismuth 212. And bismuth has 83 protons. And one of there are two possibilities for the bismuth at the moment. First, the first one is that the neutron changes to proton is going to be polonium again, 84, and another choice is thallium. Okay. Thallium means bismuth reduced proton by 2, so 80 will be 80, or 83 will be 81, and the polonium will decrease, will reduce its proton by 2. Okay, bismuth 83, this is 84, 84. Reduced by 2 will be 82, which corresponds to lead 208. And thallium 208 will change its neutron to be proton, so thallium, which is only 81, will be 82, and that corresponds again to lead 208. All right, this is the thorium-232 process. It also includes the alpha. Now let's move to the next decay, next type of decay, that's gamma decay. The nucleus undergoes radioactive decay. that causes alpha emission, beta emission. However, the daughter nucleus often remains in an excited state, which appears to be unstable. The daughter nucleus undergoes another decay to a lower energy state, perhaps to the dry state, caused by the proton and the neutron in the nucleus that move from a higher energy level to a lower level. That will emit extra energy in terms of photon, whose name is gamma ray photon and gamma. Okay, the mobile phone is still working perfectly. ฮะสุดที่โรงพักเลยเหรออ๋อเป็นทำไมอ่ะคุณไปขโมยไข่ไก่หรือว่าไงคดีอาญาคดีอาญาขโมยไข่เอเลี่ยนครับเรียนแบบจับดีเวอร์สวัสดีครับอาจารย์สวัสดีครับต่อไปครับ and the typical gamma energy is from 10 kilo electron volt to 5 mega electron volt. Gamma decay that takes place after an alpha decay is given by the following sequence. If you start with radium-226, of course, it's going to reduce the number of nucleons by 4, and you get radium. You get only anything.
เนี่ยกูกรีดชื่อมึงได้เดี๋ยวกูกลายเป็นคำสาปให้กู
ไม่น่าได้ใช้แล้วครับวันสองวันนะผมทำตกพื้นมาเนี่ยครับลูกมือก็อาจจะมีแข็งๆแต่เมื่อเช้านี้ก็อัดได้ปกตินะไม่รู้เป็นเพราะอะไรอาจจะร้อนแอร์ตกตึกนี้โหทัพนี้ได้โควต้าของท็อป50เลยใช่ปะไปใช่ครอบครัว
แต่เราต้องเป็นเทรนเกรดถ้าจะได้เต็ม
เป็นทีนะเดี๋ยวว่า
เพราะว่าอาจารย์แจกเกรดนะครับ
ก็ว่าตามเรื่องผ่านคุณอย่าตกติครับ
อย่าโตสิ
รอบนี้น่าจะเอาข้อสอบยากขึ้นแล้วสำหรับผมนะ
ว้าไม่ใช่การไล่
มาผมออกยากแต่ว่ามาให้คุณทำน่าจะง่ายเพราะว่ามันไม่ต้องคำนวณให้คุณกายอย่างเดียวแบบนี้เพราะว่าเขาไม่ให้ใช้เครื่องคิดเลขถ้าเป็นเครื่องคิดเลขผมก็ออกง่ายๆไปอันนี้ผมจะออกยากเพราะว่าจะทำยังไงให้แบบเราไม่ต้องใช้เครื่องเลข
อาจารย์จะพูดเรื่องนี้แล้ว
อ่ะ
เครื่องคิดเลขนี้แล้ว
ก็ใช่ไงผมเดี๋ยวคุณดูถัดไปอ่ะคุณทศนิยมลึกเลยแล้วมันจะไม่ใช้เครื่องคิดเลขได้ไงเดี๋ยวดูเนื้อหาถัดไป
แล้วก็คือตอนเราจะมีเครื่องเลขแล้ว
เขาจะไม่ให้ใช้เครื่องคิดเลขไงแต่ว่าคุณดูเนื้อหาบทเนี้ยทศนิยมลึกเลยแล้วมันปัดเป็นอินทิเจอร์ไม่ได้เพราะว่าไอ้ทศนิยมนั่นแหละมัน meaningful มันแปลงเป็น energy สำหรับผมเนี่ยทำคุณเป็นอินทิเจอร์อย่างเดียวอ่ะเลขจำนวนเต็มอย่างเดียวมันพอมันลบกันก็เป็นศูนย์มันก็จะไม่มี energy ได้ผมก็งงใจกับกระทรวงศึกษา
ไม่ใช่ได้ไม่ใช่อาจารย์ขึ้นอยู่อาจารย์ด้วยอาจารย์บอกว่าให้ใช้เขาก็เลยไม่ได้
ไม่เขาไม่ให้ใช้คุณยังไม่ให้ใช้เลยเดี๋ยวผมเปิดให้ดูเนี่ยเขาเขียนมาเลยนี่เลยครับไหนเนี่ยข้อ2เนี่ยในการออกข้อสอบปลายภาคโครงการขอความร่วมมือจากข้อสอบวิชาวิทยาศาสตร์คณิตศาสตร์แบบไม่ให้นักเรียนใช้เครื่องเลขตามแนวปฏิบัติการวัดและประเมินผลตามบริบทของทางเรียนแต่ในอะไรคอริคูลัมของวิชาเนี่ยผมก็ไม่ได้เขียนว่าผมจะไม่ใช้เครื่องเลขนะแล้วผมก็ไม่ได้เขียนว่าผมจะใช้ทำไมครับแต่มีคนโทรมาบอกครับว่าเป็นเพราะกระทรวงของมันตรวจไม่รู้จริงหรือเปล่านะแต่เขาโทรมาบอกตรวจแล้วเขาบอกว่าไม่ให้คุณใช้นะครับโอเคlet's continue our story Okay, carbon dating is the topic about measuring the time of an ancient object. Okay, as mentioned earlier, in the introduction to this chapter, carbon-14 is the radioactive isotope of the carbon nuclei, right? So physicists use the radioactive property of carbon-14 to measure the life of the age of the ancient object. Carbon-14 is unstable because it's the radioactive isotope, and it has a long half-life. The half-life of carbon-14 is 5,730 plus or minus 40. Okay, and this is the toleration. In our world, carbon-14 is created by cosmic rays, which are high-energy particles from outer space. It's a form of alpha particle or beta particle. Okay, they were created from deeper space, and they travel to our world, to our Earth, at the high atmosphere level. Well, usually you know that in our world we have the atmosphere, right? And the atmosphere will contain the air, and the air has nitrogen. Nitrogen-14 is the common isotope in the air. And once the neutron from the cosmic ray reaches the nitrogen-14, we're going to get carbon-14 together with proton. Okay, neutron kick one proton out, and it just stay with the nucleus of carbon. These take place usually in the upper atmosphere, which is around 9 to 15 kilometers above the ground. And that atmosphere includes troposphere and stratosphere. The ratio of the carbon-14 and carbon-12 is constant, and is approximately 10 to 12. So carbon-12 is much larger than carbon-14. The number of carbon-12 is much larger than the number of carbon-14. This figure illustrates how the nitrogen-14, carbon-14 is created in our world. The cosmic ray from deeper space. Let me check ไป ขออนุญาตดูโทรศัพท์เจ๋งนะเลิกเหรอเป็นอะไรไม่รู้วันนี้ครับน่าจะเป็นเพราะใช้อัดอั้นโอเคสั้นไป You have cosmic ray, which is a kind of, it contains alpha particle or beta particle or proton, okay, not beta particle, it's proton and alpha particle, because some sources just explode and they emit alpha particle and proton. You know that universe is made of elementary particles like proton, neutron, and sometimes they stay together in terms of alpha. But they have kind of energy. They move to everywhere in the universe, also here on Earth to atmosphere, to our atmosphere. It reaches the upper atmosphere, including troposphere and stratosphere, and there is collision with the atmosphere, and it produces neutrons. Neutrons will hit the nitrogen-14. ใช่ศิลวิทย์สุขีป่ะ ใช่ปะปกติศิลวิทย์สุขีเขาจะไม่โดดไม่ใช่เหรอ
ก็มันอยู่ที่เขาไม่เรียน
ไม่มีเรียนเหรอเนื่องจากอะไรครับ
เป็นอาจารย์เขาคุยเรียนสอน
ใช่อาจารย์คนที่สอนคุณเมื่อกี้นี่ป่ะที่ไปสอนห้องนู้นใช่ป่ะ
ไม่ก็คือแบบเขาไม่ได้เรียนอะไรมาเฮ้ย snitch เขาก็สอนเลย
เหรอเขาก็สอนอยู่
แต่ว่าเขาไม่ได้สอนไม่ได้
แล้วปกติพวกศิลวิทย์สุขีอะไรนี่เขาจะไม่โดดนะเขาจะเป็นแบบ
เขาพูดเรื่องเนื้อหาต่อ
หรือว่ามันไม่สำคัญอย่างเงี้ยหรอก็เลยกลับบ้าน
ก็มันเหมือนปกติอาจารย์ผู้หญิงเป็นคนสอนอาจารย์คนนี้เขาเพิ่งมา
อ๋อคนนี้เข้ามาใหม่เขามาแทนเหรอ
ไม่คือเขาเป็นคนที่อาจารย์เป็นคนสอนตอนแรกแล้วอาจารย์เขาไปที่เขาเลยให้อาจารย์ผู้หญิงสอนมา
อ๋อแล้วทีนี้กลับมาแล้วอย่างเงี้ยหรอ
น่าใช่หรือเขาสลับกันหรือบางวัน
อ๋อสลับกัน
ใช่
โอเคครับพอเข้าใจแล้วยังไงไม่ถูกใจศิลวิทย์สุขีปกติศิลวิทย์สุขีจะตั้งใจเรียนมากนั่งหน้านั่งอะไรโอเคห้องนู้นก็เลยออกจากห้องกันมาเยอะแล้วOkay, carbon 14 is unstable, and once the neutron hits the nitrogen 14 nucleus, it's going to create the proton, and this will cause carbon 14. In carbon 14, once they in the atmosphere, it is surrounded by oxygen atoms, and it just combined. It is combined to combined with oxygen, and it's going to be carbon monoxide. Carbon monoxide can attract one more oxygen. Okay, it's going to be carbon dioxide, and this process is called carbon dioxide. Carbon monoxide oxidized into carbon dioxide, and the plant will absorb carbon dioxide to photosynthesis process, okay, together with the photon from the sun, okay, in order to produce the food for plant. Okay. The plant will absorb carbon 14 inside its body, and animal and human would have the grass or tree or plants as their food, and then carbon 14 will be also absorbed into the human body or animal body. Human also eat animal body in terms of meat or steak or beef, something like that, like cow or pork or pig. Okay. Yeah, of course, our human body would contain carbon 14, and humans use this idea to compute or estimate the age of the ancient object. Now let's consider the summary of the creation of carbon 14 and the generation of and the falling down process of the carbon 14. First we have neutron hits the nitrogen 14 nucleus, and it kicks one proton out of the nucleus of nitrogen 14. Now it becomes carbon 14 because the number of proton is now 6, okay, instead of 7 as earlier. Decay of carbon 14 is the following. Carbon 14 just split itself by 5,730 years into nitrogen 14, and it has one electron. Okay, electron just stay somewhere else, and we would have also antineutrino. Okay, this electron was created by it was created inside the nucleus here. We have also electron antineutrino, and here is the figure that you see the cycle of the generation and the decay of the carbon 14. You start with neutron together with nitrogen 14. You get carbon 14 together with one proton, and the carbon 14 is split into nitrogen 14 with one electron and electron anti-neutrino. The number of molecule, the number of mole for carbon 12 is around million, okay? Million of carbon, number of mole of carbon 14. But once carbon 14 decays, okay, this ratio would, this ratio would change. Okay, the number of carbon 12 will be greater than the number of carbon 14, but the ratio of both isotopes will change. Now, we go to the background of every organism so that we can use this idea, is fundamental to measure the age of the ancient object. Okay. Every living organism would have the same ratio of carbon 14 and carbon 12 all the time. But when it passes away, okay, they will not absorb carbon 14 from the circumstance anymore. So the ratio between carbon 14 and carbon 12 would change. It would degrade somehow. And even they are living, they exchange all the time carbon dioxide with their surroundings. Once the organism dies, okay, it no longer absorbs the carbon 14 from the atmosphere. Carbon 14 continuously decays with the half-life of 5,730 years. So the ratio of carbon 14 to carbon 12 will decrease as a result of beta decay in carbon 14. By measuring the proportion of carbon 14 in the remains, we can determine how long ago the organism died. And it's possible to determine the age of material, especially ancient material, by measuring its activity per unit mass as a result of the decay of the carbon 14. In one of the application is shown in this example, which might be included as one of the problem in the final examination. The activity of the atmospheric carbon due to the presence of carbon 14 is about 0.255 becquerel. You know, becquerel means becquerel is very fundamental unit to the radioactivity. So it's one declined nucleus per second. So this is per time actually, unit per time. 0.255 is the decay rate, the activity, the disappearing rate of the carbon 14 per gram. Okay, and so if you have 1 gram of carbon 14, you're gonna have 0.255 nucleus per second that decays. what fraction of the carbon atom are carbon 14. So you need to find the ratio between carbon 14 and carbon 12 from this process. And if the activity of an archaeological specimen is 0.0637 becquerel per gram as well. 1 gram, the activity, the rate of disappearance of this ancient object is 0.637. What is its approximate age? So we're going to use the carbon dating idea to determine how old this ancient object is. The mass of the Avogadro number of the carbon 12 isotope can be computed by the following. You just find the number of molecules or atoms for 1 mole, and this is known in this well study, which is known as the Avogadro number, which is 6.022 10 to 23 atoms per mole, which pick up a matter of 1 mole, you're going to get 6.022 times 10 to 23 atoms per mole. Atoms that could be found from that 1 mole. And you have to convert you have to change the mass unit from atomic mass unit to the gram. Okay, so it corresponds to 1.66 10 to 4 gram per atomic mass unit. And you have to multiply how much mass in 1 mass unit per atom. So in 1 atom we would have 12 atom mass. We have 12 atom mass unit for 1 atom. So once you multiply all these numbers, you get 11.9999712. That could be approximated as 12 gram per mole. So if you pick up carbon 12 by 1 mole, you're going to find that your carbon has the mass of 12 gram. In the standard, carbon 12 is approximately subject to 12 gram per mole. The carbon 12 mass of 1 gram is equal to 1 by 2 moles. So yeah, that's the amount of carbon 12 by 1 gram. Okay, it's only 1 by 12 mole. And you can find the number of atoms by divide the number of Avogadro by 12, and that's equal to 5.018 10 to 22 atoms. The number of the carbon 14 could be found from the rate like this. Okay, if you know that the rate of decreasing nuclei would be decay rate times the number of objects at that moment with the minus sign because it signifies decreasing. So when we substitute it, the decay rate can be determined from half-life period, right? Half-life in seconds. And here is the rate of change of the nucleus per time. Okay, and once you move the half-life to the numerator, you can have half-life like this. Okay, the rate of change of the carbon 14 is available in the problem. Here they say carbon 14 with 0.255 becquerel. Becquerel means the number of disappearing nucleus per second, right? Okay, the rate of disappearance of nucleus per time. It's available in the problem. Okay, they just provide this information to us. You just substitute it into this location, but keep in mind that this is a decreasing quantity, so we're gonna leave it with the negative side. One of the complicated thing is the conversion of half-life, which is 5,370 years, to the SI unit of time, okay, which is second. Okay, we know that in 1 year we have approximately 365 days. In 1 day we have 24 hours, and in 1 hour we have 60 minutes, and in 1 minute we have 60 seconds. That's all, okay, because we already reached the final unit of time, which is second in the SI system. Log 2 is log 2, okay, just leave it like that, and by using the calculator, you're gonna find that the number of the atoms that is in decay process is 6.6, okay, at that time is 6.64, 10 to 10 atoms, okay. During this decay process, we have the number of atoms for carbon 14 like this. So as in the first question, they would like to the ratio between carbon 14 to carbon 12, right? Before we know that, you just divide the Avogadro number by 12. That will be the number of atoms for carbon 12. But carbon 14 number of carbon 14 could be found from the decay rate like this at that moment, which appears to be 6.6 10 to 10. You can see that the amount of carbon 14 is much less than the amount of carbon 12, okay, 10 to 22 and 10 to 10. Once you divide it, you're going to get the ratio which is much less than 1, okay, 1.32 10 to 12. And that's for the first question, okay, the fraction of the ratio of carbon for carbon 14. Now let's move to the second question. How long does this specimen is? Okay. How long does this specimen is? So the ratio could be found from the ratio of what could be the rate. Okay, could be considered in terms of rate. Rate of decay, right? Which is 0.637. That's the rate provided in the question, and the rate of carbon 14, which is 0.255, like this. Okay. These rates could be used in the typical formula in the decay rate topic. Lambda n is equal to n0 and 1/2, right? When you multiply both by lambda, so which is decay rate, you're gonna get rate like this. Okay, activity of specimen equal to activity of carbon 14 multiplied by 1/2 and T divided by half-life. And once you move activity of carbon 14 to the left hand side, it's going to appear as the denominator, and 2 with the power of something would stay on the right side. But this ratio rate of activity of specimen and activity of carbon 14 was calculated before in equation 76. We use that number for the left hand side, and in order to determine the variable t, which is the time we want to know how long does that object last, we just take the logarithm function, and usually we're going to use the natural logarithm, which is log function, and we move log to the left hand side, and we move period to the left hand side as well. We're gonna get the quantity like this, okay, and we just substitute the half-life, okay, because we want to deliver the answer in terms of year. We will not say the answer in second. Okay, that's fine in the mobile phone. We don't need to convert the half-life to the second anymore because it's easier to say the age of the ancient object in terms of year. Okay, you can see that once you use the calculator, it turns to be 11,466 years. Please note that the time here is negative. The time here is negative. What is the reason behind that? Because this means this is the time in the past. Okay, so this object has lost its life in the past by 11,466 years. Okay, เวลาที่ติดลบก็หมายความว่ามันย้อนไปข้างหลังนั่นเองครับโอเคไหมถ้าเวลาเป็นบวกก็คือว่ามันจะไปข้างหน้าเวลาย้อนไปข้างหลังก็คือว่าวัตถุโบราณชิ้นนั้นมันถูกตายถูกเสียชีวิตมาตั้งแต่กี่ปีแล้วนะครับโอเคไหม11,466 years approximately. Okay, now one of the disturbance nowadays is that because the earth changes to the industrial era and there was a steam turbine engine, there was car engine, there was also nuclear weapon testing. Okay, all of these activity would create also additional carbon instead of the typical carbon in the nature. And the ratio between carbon 14 to carbon 12 would change a little bit. But anyway, if you compare it to the table, you can expect or make the correction to what you have calculated in this result. Okay. Now we move to the nuclear reaction topic. Nuclear reaction topic talks about the activity that humans try to disturb the nucleus in order to get another nucleus. The reason why we have this topic is that gold is one of the elements that we would like to have, right? Because gold is precious. Gold is if you will be millionaire if you have too much, so much gold, right? The chemistry or the physicists try to change the element to be gold. That's why they try to bombard some nucleus in order to get the gold nucleus for that purpose, for the sake of millionaire. But one of the experiments is that in 1990, Rutherford bombarded nitrogen with air particle. Okay, that air particle was created by radioactive sources. Okay. And he discovered a new process. Okay, he got oxygen element or nucleus like this. Helium-42, which is air particle, hits the nitrogen 14. You get oxygen 17 together with typical hydrogen. Okay, so this was the first nuclear reaction process that was discovered on Earth. Okay, this process is known as a nuclear reaction. 13 years later in England, I think Rutherford was also in England, right? Okay, 13 years later, also in England, another guy whose name is Robert Chadwick bombarded beryllium, okay, which is a smaller nucleus than nitrogen, only beryllium-94, okay, this is nitrogen 14-7. And he bombarded a smaller nucleus, which is beryllium, and the result turns to be carbon 12, together with a smaller nucleus, which is unknown to this problem. And we would like to know what this particle is. Okay, it just provide in terms of general form of atomic representation notation. Okay, the nucleus name is X, which is unknown. Okay, X is used to represent something that is unknown. And the number of nucleons is A, number of protons is Z. So in order to find this number, you need to find A and Z and C, right? In order to do that, okay, in chemistry they have the process, right? You have to balance them in some manner. But for us in physics, you have to balance this equation in terms of number of nucleons and number of protons, okay, the lower number. You need to combine all of these, okay, at the input side and the output side. 4 plus 9 will be 13, okay, on the left side. And on the right side we have 12 plus 8. Okay, and you can see that in order to get to 13, okay, you have to add 12 by 1. Okay, so we have 1 at the location of the number of nucleon. And in the atomic number location, 2 plus 4 would be 6, but we have already 6 here, so that in this case would be 0 in order to make this equation balanced, right? Z will be 0. So you now can get the interpretation of this symbol, because we have only 1 nucleon, we don't have any proton, and that symbol would mean neutron, right? Would be neutron. Okay, now we can deliver the answer. This missing or unknown particle is just neutron. Okay, now let's talk about something more, okay, apart from the identification of the element. The energy is also an important quantity in physics. Reaction energy Q could be found from the mass difference multiplied by the c squared. This equation comes actually from the Albert Einstein formula E equal to mc squared, right? Exactly the same thing, but mass change is only the mass difference. Okay. There are 2 possibilities for this equation, because there is subtraction, right? It can happen that Q is positive or Q is negative. Okay. In the positive energy case, it means that the total mass decreases. That's why the mass. That's why we have more energy, because the mass is converted to energy. Okay, the mass difference is converted to energy, so we have more energy. The energy that we have in the positive term here is converted to the kinetic energy for the movement of the remaining particles. And in the negative energy case, it means the mass increases. In this case, it cannot take place automatically. You need to put more energy at the beginning. Okay, you need to accelerate the mother nuclei with high energy, so that it can be converted to the output. The first reaction is known as exothermic reaction in physics in our society, and known in chemistry society as exothermic. Okay, because in thermodynamics or in chemistry they are paying attention to thermal, right? To temperature, but not for us here. In the second case, when the energy is negative, it's known in physics society as endothermic. As discussed in M604, exo means external, right? Yeah. And endo would mean internal, right? The energy inside the process. Okay. And in chemistry society, they say this process as endothermic reaction. Okay. Now let's talk about the calculation of reaction energy from this example. We have lithium 73 which is bombarded by proton. Proton, of course, is only the nucleus of hydrogen. And the result turns out to be two alpha particles, two pieces of helium-42. So determine the reaction energy Q. Well, let's see what happens. Of course, we are going to follow the equation 83 Q equal to the mass difference times speed of the light squared. Okay, mass of hydrogen, mass of lithium, and mass of hydrogen, mass hydrogen again. And just look at the table and write down those numbers, the masses of these four particles. Okay, this is the mass of hydrogen or the proton, and mass of lithium 73, mass of alpha particle, but twice because we have two pieces of the alpha particle. So the next one is C-square. Okay. If you compute it in the SI unit or in kilogram, you have to use 3 times 10 to 8 square, right, with the power of 2. But if you substitute it in atomic mass unit, you just use the simple conversion manner, which is only 931.5 megaelectron volt per atomic mass unit. After the subtraction, you get mass difference of 0.018 atomic mass. This is what I worry about the final exam, because we are not allowed to use the calculator, electronic calculator. เขาห้ามใช้และอาจจะเป็นเทอมต่อไปด้วยมั้งรุ่นน้องอะไรผมสอนมาตั้งแต่ที่แรกไม่เห็นมีใครมาห้ามเลยเป็นครั้งแรกแล้วไม่ใช่ตั้งแต่เทอมนะต้นเทอมนะเขาเพิ่งมาห้ามแค่ครึ่งเทอมหลังเนี่ยอีเมลมาผมไม่เข้าใจอะไรของกระทรวงศึกษาโอเคนายเลย31อะไรนะกระทรวงเลยมีคนกระซิบผมบอกว่ากระทรวงเขามาดูข้อสอบแล้วผมเขียนไว้ว่าอนุญาตให้คุณใช้เครื่องคิดเลขแล้วเขาบอกว่าไม่ได้แต่เขาไม่ลงในรายละเอียดเลยอาจจะเป็นครูภาษาไทยมาตรวจว่าทุกวิชาในม.ปลายห้ามใช้เครื่องคิดเลขแต่เขาไม่ลงรายละเอียดเลยว่าอย่างเนี่ยคำนวณพวกตั้งแต่ต้นบทแล้วอะไรbinding energy mass difference มันต้องดูจากตารางซึ่งตารางมันทศนิยมมันลึกเห็นไหมครับจากความเป็นจริงนะเพราะฟิสิกส์มันเป็นวิชาความเป็นจริงเขาวัดมาได้ดีก็คือเท่านี้ยกเว้นคุณจะไปวัดที่บ้านเองได้เลข 1 เลข 2 เลข 3ไปเลยแต่มันไม่ใช่ไงเครื่องมือเขาแม่นยำนะมันถึงได้ทศนิยมขนาดนี้นะครับก็ต้องว่าตามนี้แต่เขาไม่ยอมให้ใช้เครื่องเลขก็แล้วแต่เขาผมไม่ว่าอะไรโอเค you have the mass difference which is positive it means it's exoergic process like this one you multiply with 931.5 and you're going to get the energy of 17.35 megaelectron volt. Okay, this is exoergic. The energy that you get would be converted to kinetic energy of the outcome, which are two pieces of helium 42 or alpha particle. Alpha particle would have more kinetic energy by this amount, 17.35. So the proton or the alpha particle would have much more speed, okay, by this energy. And bombardment in 84 separate the nucleus, mother nucleus into two alpha particles, and you get 17 megaelectron volt as the additional energy. It means this energy will increase the initial total kinetic energy by 17.35. Another example is the Rutherford experiment, which bombards the bigger nucleus or nitrogen-14, okay, apart from beryllium, right? Lithium 73. Okay, the result tends to be oxygen and hydrogen. And we just compute the mass difference again. We look at the table and leave the value of atomic mass of helium-42 and atomic mass of nitrogen 14 Sem, and atomic mass of oxygen 78, and mass of proton as well. Okay, you just compute the you just convert C squared to be 931.5 as well, and you compute the difference and combine multiply it with 931. But the mass difference here is negative. Okay, it turns to be a negative quantity, so it means this is endoergic process, right? It means the output would have reduced kinetic energy by this amount, 1.192. Okay, the amount of 1.192 megaelectron volt energy is absorbed in the reaction. Okay, the particle would move slower because they spend this energy for breaking the nucleus of nitrogen 14. Okay, that Rutherford reaction would take place if you have enough energy by 1.192. If you have fast movement for the alpha particle, you can satisfy this process, and this process will take place. Okay, the endothermic actions will not occur except that you have enough kinetic energy for the bombardment to overcome the energy deficit or the binding energy inside the nucleus. Now we move to nuclear fission. Nuclear fission is the decay process in which nuclear reaction is the process that is made by human. Okay, it's man-made process, it's man-made experiment. But nuclear fission will take place. Nuclear fission will take place naturally without any attempt from the human. Okay, nuclear fission is a decay process in which unstable nucleus splits into two smaller nuclei, or there is a specific word for that. It's called two fragments of comparable mass. The masses of both particles are quite close to each other. มันก็ไม่เจ๋งแล้วนะทีนี้ไม่รู้เป็นอะไรครับดีสตาร์ทเครื่องก็หายเลย Okay. In such a reaction, the total mass of products is less than the original mass of the heavy nucleus, because this is the exoergic. Okay, this can happen in nature. Mass difference is converted to kinetic energy. In fission process was discovered in 1939 by two German physicists or experimentalists, Otto Hahn and Fritz Strassmann. They bombarded the uranium-235, which is a very active version of isotope of uranium. They bombarded uranium-235 with neutrons. Okay, according to the following equation, nitrogen with kinetic energy hits the uranium-235. This process is very important because this is the beginning era of nuclear weapon. Okay, nitrogen was accelerated and it hits the uranium-235. It becomes uranium-236 immediately. But when neutrons stay inside the nucleus and the nucleus is too big, this nucleus will not be stable and it's going to be split into the other nucleus or two fragments to smaller nuclei. And it also creates the neutron, okay, neutron with some amounts of neutron. It depends on the balance names of this process, this equation. Uranium-236 with star is an intermediate state of the nucleus that lasts only around 1 picosecond, okay, 10 to minus 12 seconds, okay, very, very short. It's going to be broken down into two fragments such as nucleus X and nucleus Y. And this is called also as fission fragments for the specific name here, nuclear fission. In capital N, we subscript small n is the number of neutrons that could be produced in this process. Okay, and that's all for today's lecture because we reached the same point as the lecture in M604 โอเคเราจบไว้เท่านี้นะครับแม้ว่าจะเหลือเวลา8 นาทีเพราะว่ามันเนื้อหามันเข้ากันนะเดี๋ยวมันจะล้ำหน้ากันไปครับโอเค see you on Friday afternoon right บ๊ายบายครับสวัสดีครับ
สวัสดีครับ
สวัสดีครับ
สวัสดีครับ